Welcome back. Now we'll discuss wind energy conversion system. Objectives of this presentation are to discuss wind energy potential in India and to discuss various types of wind machines and systems. Wind energy is one of clean, inexhaustible and major source of renewable energy. Man has been used wind from 12th century for grinding grains and in shipping. As fossil fuels are finite, exhaustible, so world focus their attention on solar energy and wind energy and other energies for electricity generation. In India, we have National Institute of Wind Energy established in Chennai in 1998 by the Ministry of New and Renewable Energy Sources for research and development of wind energy installations, and National Institute of Wind Energy decide the goal to install 60,000 megawatt capacity by 2022, and the same institute estimate the wind energy potential at 100-meter tower height equal to 302 gigawatt, and the total installed capacity of India is 368 gigawatt, and the wind energy potential for 100-meter tower height is 302 gigawatt. In estimating potential of wind, National Institute of Wind Energy classified the potential according to land, that rank 1 is for the wasteland, rank 2 is cultivable land, and rank 3 is potential for forest land. This table shows the wind energy potential in India in various states, and the highest wind energy potential is in Gujarat. In rank 1 is in hilly region, wasteland. The potential is 52,287 megawatt, and in rank 2, that is cultivable land, the potential is 32,037 megawatt, and in rank 3, that is forest land, 105 megawatt is the potential, and the total potential in Gujarat is 84,431 gigawatt. Gujarat is followed by Karnataka, having the wind energy potential in rank 1 15,202 megawatt, for rank 2 39,802 megawatt, and for rank 3 852 megawatt, and the total potential in Karnataka is 55,857 megawatt. After Karnataka, wind energy potential is in Maharashtra, and in hilly region the wind energy potential is 31,154 megawatt, in cultivable land 13,747 megawatt, and in rank 3 492 megawatt, and the total wind energy potential in Maharashtra is 45,394 megawatt. Maharashtra is followed by Andhra Pradesh having total potential 44,228, followed by Telangana having total potential, not Telangana, Tamil Nadu having total potential 33,799 megawatt. So this is about the wind energy potential in India in various states, and the total potential of rank 1 is 153 gigawatt, and in rank 2 146 gigawatt, in rank 3 3 gigawatt, and the total potential in the country is 302 gigawatt. This map shows wind power potential of India at 3-meter tower height, and this is the typical wind energy potential spread overall the India in different states. Total installed capacity of the country is 368.98 gigawatt at the end of February 2020, and the renewable share in that total installation is 23.39%, and 226% increase in capacity of renewable energy in 5 years in the country. Now India is on the 5th position at global level in renewable energy installation. Factors causes wind. There are two factors: the absorption of solar energy on the Earth's surface and in our atmosphere, the rotation of Earth about its axis and its motion around the Sun, alternate heating and cooling of surfaces. This cycle causes the wind, and the pressure difference caused by heating and cooling blows the wind. Now we'll discuss types of wind. Typically there are two types: planetary wind and local winds. Planetary winds are causes due to difference in heating between equator and south and north pole. The heating is more at equator, so air is get heated and moves up. Its place is taken by cold air. So cold air blows from south pole to equator, and as Earth is revolving around it and around the Sun, so directions of planetary winds are not fixed. Then second type of wind is local winds, which is due to the different heating pattern on land and sea and slope and valley. In a land is get faster heated, so in a day land is get faster heated, and so cold air from the sea surface blows over the land, and in night land get cool faster, so the air from the land blows toward the sea in night. Similarly, slope get heated faster, so the cold air from valley blows toward the slope, and in night slope cools down faster, so the cold air blows toward the valley. So in this way planetary wind and local winds blows. Now we will discuss different types of wind machine. According to axis of rotation of rotor, there are two types: horizontal axis machine and vertical axis machine. According to rotor design, we have four types: multi-bladed machine, propeller machine, Savinius rotor, Darius rotor. Various type of rotors are shown in this diagram. First is multi-bladed type, second is propeller type, third is Savinius type, and this one is the Darius rotor. Now we'll discuss all the rotors, four rotors: multi-bladed, propeller, Savinius, and there is rotor in details. So first is multi-bladed machine consisting of number of blades, and the number of blade varies from 12 to 20, and the rotor consisting of two rings, inside ring and outside ring, on which blades are mounted, and the inner tip of the blade is mounted on inner ring, and the in between the blades are supported by second ring, and when we move from inner side to outer side, the width of the blade go on increasing, and the blades are fixed in a proper angle such that the drag force exerted on the blade are maximum. This is a slow rotating rotor, slow rotor, and it is mounted on the shaft called as hub. So this is the photograph of the multi-bladed machine, and this is the schematic. So these blades are mounted over the hub, and that hub is mounted on the shaft, and the shaft is connected to the gearbox, and then gearbox is connected to the connecting rod and crank mechanism, and crank and connecting rod mechanism convert rotary motion into reciprocating motion, and that reciprocating motion is used to operate the water pump. And at other end of the shaft, the tail vane is provided, and the function of tail vane is it maintain the rotor in direction of wind to extract maximum wind energy. And this is the multi-bladed machine having rotor, then the hub to which blades are fitted, then we have power shaft, then it is connected to gear, then we have crank which convert rotary motion. Crank is connected to connecting rod, and to convert rotary motion into reciprocating, and the connecting rod at the end is connected to the water pumping system, and we have tail vane to, to maintain the rotor position in direction of wind. And the application of multi-bladed machine is for grinding of grains and for pumping of water, and it is a slow speed machine and it gives more torque. This is the second machine, propeller machine, which is widely used in world for power generation, and it consisting of finite number of blade. The blade may be 1, 2, 3, 4. Typically 2 or 3 bladed propeller machines is used in wind farm in the world for generation of electricity. We have here the schematic of propeller wind machine. This is the blade. This is 3-bladed machine. Blades are mounted on the hub, and this hub, at the root of the blade we have the pitching mechanism which rotate the blade. Then this hub is mounted over the shaft, and shaft is connected to the 3 that bearings, and then we have this is the nacelle in which we have different gearbox, shaft, generator are placed. Then we have 5th is a gearing, then 6th is roller assembly, 7 is generator, and last one is power. And this is the typical photograph of 3-bladed propeller wind machine, and the blades are aerofoil in cross section. So this machine is rotating due to the lift force and not drag force, and due to aerofoil shape the lift component is increases and the drag component decreases. So lift action, lift force rotate the propeller rotor. In this case, these aerofoil cross section blades are mounted on hub, and at the root of the blade we have pitching action. So when wind speed vary, we can adjust the angle of attack of the blade so that the maximum benefit of energy conversion can be taken. And with related to this machine, we have three velocities. One is cut-in velocity, means the velocity at which this machine starts generating electricity, and below that velocity the machine consumes electricity which is required for excitation of winding, which is more than the energy generated by wind machine. So the for getting output, the machine should be operated when the wind speed is more than cut-in speed, means more than 3 or 4 meter per second. Then we have rated speed at which machine is designed, and typically in propeller machine the design speed taken is 11 to 12 meter per second. Then we have cutout speed at which the machine is stopped when the velocity is too more, and it is 30-40 meter per second, at which the functioning of machine is stopped to avoid the damage. And then we have third speed is furling speed. Its maximum speed 70-80 meter per second, at which the machine can sustain, and it is designed mechanically for that speed. So this rotor, when the speed is too high, this pitching mechanism rotate the blade such that the forces acting on the blade is less, and the rotor will rotate at rated speed. When the speed is too low, the pitching mechanism arrange the blade such that maximum force will get exert, and the rotor will produce maximum power. And another component is nacelle, in which we have gearbox, various components and generator, and it is mounted over the top of the tower on the yaw mechanism. So yaw mechanism rotate the rotor in the direction of wind. So yaw mechanism consisting of sensor which sense the direction of wind and keep the rotor in the direction of wind by yaw mechanism. So this is fast speed rotor. It rotates with the lift force, and in world it is used for power generation, and this is the main wind energy generator in the world used for generation of electricity. Now we will discuss next wind machine, Savinius rotor, and it is a vertical axis wind machine. First two multi-bladed and propeller machines are horizontal axis wind machine. Now next two Savinius rotor and Darius rotor machines are vertical axis rotor, and this is the axis of this rotor, and rotor is formed from the two half cylinders, and at the joint we have the shaft about which this rotor rotates. Now this is the wind stream blowing on this half cylinder and exert drag force, due to which this rotor rotates, and this half portion also rotate and comes in front of wind stream, and wind stream exert force on this portion. So in this way Savinius rotor rotate, which is the slow speed rotor gives more torque and less speed, and this is the actual rotor Savinius type. We have two half cylinders are jointed, and at the joint we have the shaft about which this rotor rotates. Then another vertical axis rotor is Darius rotor. In Darius rotor we have 2 or 3 or 4 blades, and this is the photograph of Darius rotor with 2 blades. This is blade, and this blade is having aerofoil cross section, and again this machine rotate due to the lift as the blade cross section is aerofoil, and these bearings are provided at the two end of blade, and over this vertical shaft these blades are fitted, and at the bottom we have gear and other mechanism and generator. And in this another diagram we have Darius machine with a 3 bladed, and this is vertical axis rotor. It is high speed rotor, and it rotate due to lift and not the drag. So we have discussed 4 type of rotor: multi-blade rotor, which is vertical axis slow speed rotor; second, propeller rotor, which is very common in the world for power generation, and typically 2-3 blades are used for in the propeller machine, and it is high speed machine. And then we have discussed the 2 vertical axis rotor, Savinius rotor and Darius rotor. Now we'll discuss the wind farm. So wind farm consisting of number of propeller type of machines mounted over hills or wasteland, and the numbers may be 200, 300, 500. That depends upon the size of wind farm, and the energy generated by the wind energy generator of propeller type is supplied to the transformer, which step up the energy voltage, and then that voltage electricity at high voltage is supplied to the grid. So in wind farm at one place we have substation, which consisting of various transformer, step up transformer, then circuit breakers and other electrical equipments, as well as the infrastructure for office and control room. So this is one of the picture of wind farm. Now we'll discuss wind energy conversion system. We have the types of wind conversion systems are grid connected system, standalone system, battery storage system, solar PV, wind hybrid system. So in a grid connected system, the wind energy generate electricity. It supplied to the transformer, and the voltage transformer step up type, and voltage is increased and power is directly connected supplied to the grid, and customer takes the power from the grid. Means all power plants including renewable, non-renewable, supply the power to the grid, and from the grid consumers take the power. So in this case we can use standard design of wind energy generator because there is no specific need of the application. So standard propeller wind machines or other various type other machines we can use for power generation, and depends upon the availability of land, site, and the wind availability, and generate power and supply to the grid. Then next is standalone system, in which the wind energy generator is dedicated to supply power for that particular area, particular application. And this system is typically used in remote area where grid is not available. And so the wind machine design is depends upon the requirement and application in standalone system, and standalone system supply the power to the consumer directly. Then battery storage system, in some cases wind turbines are also used to charge the batteries, and the energy stored in the batteries are used when the wind is not available. So this third type of system simultaneously supply power to the consumer as well as store the batteries, and that power we can use when the wind availability is less. Then fourth system is hybrid system of solar PV and wind. So drawback of each other are overcome by solar and wind hybrid system. In a day when sunlight is plenty available, that time most of the power generated is by solar PV system and supplied to the consumer or stored in battery. And in a night time when solar energy is not available, if wind is available, wind generator generate electricity and supply to the consumer. Now compared to single solar PV or single wind machine, the battery size required for hybrid system is less, so the cost of battery decreases and the continuous supply of power is ensured in hybrid system compared to the standalone PV system or standalone wind system. Thank you. During preparation of this presentation, the book referred is Solar Energy Principles of Thermal Collection and Storage by Sukatmi SP and Nayak JK, and also for the current data of power plant installation and wind energy potential, the website of MNRE is referred. If you have any query, mail me on sdbarate@kkwa.edu.in